Welcome everybody to the Beckhoff webinar. The topic of today, high performance with compact design, new EtherCAT terminals for evaluation of incremental signals. My name is Irina Koring, and in the next 30 minutes, I will introduce you to the general product portfolio of our EL5 series, the terminals for position measurement, with a focus of the new terminals for evaluation of incremental signals. At the end of the presentation, I will give you some application examples used by some use cases. Starting with some organizational topics. If you have some questions during the webinar, please use the question window for this. We will try to answer your questions during the webinar. My colleague Marvin Wisterhus will do it. If there are some questions for general interest, I will answer them after the session. And for sure, if we are not able to answer these questions during the webinar, we will answer them afterwards per email. Some words to my person. My name is Irina Koring. I'm with Beckhoff since 2014, and I'm product manager, especially for the position measurement terminals responsible here. Starting with the product portfolio. In the product position measurement product portfolio, we have the absolute and incremental terminals that we can evaluate. This, the encoders are always standalone encoders and mainly used if you have, for example, drive or frequency converters from different manufacturers. And these converters, for example, should be synchronized to each other. Then you use standalone encoders and can connect them directly to the EL5 terminals for evaluating signal. Also, if you have some high-speed or dynamical applications where the encoder from the motor feedback, for example, has too low resolution, you can work with a standalone encoder and also with our terminals. Starting with the absolute encoders, here we have, for example, the terminals to evaluate the SSI signals in 1- and 2-channel solutions, but we also have terminals for evaluating with C or N2.2 encoders. Not only rotative encoders, but also linear encoders can be directly connected to these terminals. Furthermore, we have also new terminals, the EL5072. It's especially interested if you have inductive probes, for example, like LVDT or inductive half bridges. But also on the incremental encoder side, we have a huge product portfolio. So, for example, the EL5021 for sine and cosine encoders, but also the HDL signals, 24-volt signals, can be evaluated with a 1-channel solution, for example, EL5151, or also with the 2-channel solutions. Mainly the RS422 or 5-volt TTL encoders are used in the industry, and here we have the EL5101 series. For example, also here we have an oversampling terminal with the option 0011. For now, now we are closing the gap in this series and have also 2-channel solutions. And we used in this context the chance and have really a complete new series, not only one, but at least with 4 new terminals. The development, or during the development of these terminals, we focused for sure on the high density and also on the high cost savings. But Beckhoff is a technical leader here, and we want to stay it. Therefore, we also implemented more functions and more performance into the series. So these are really 4 terminals with 4 strong arguments, and I want to introduce these arguments in detail. Let us check how these new terminals are now fitting into the product portfolio. Starting with the EL5101, this product is already over 15 years in the market, and here you have the chance to connect an encoder with A, B, and C track, for example, with RS422 or also single and TTL signals. If you have dynamical applications where you need more frequency or higher frequencies, you can use the 0010 option here. The new terminal is a 2-channel terminal, the EL5102, and here you already have the chance, or it's already a 5 megahertz maximum frequency terminal, and you can connect two encoders with A, B, and C track. It's not only for relating RS422 and single and TTL encoders. New here is that also open collector encoders can be directly evaluated. The pull-up resistors are integrated inside this terminal, so you don't need to wire them from the outside. This terminal is especially used if you want to synchronize many different access to each other. These terminals are also often used without motion control applications, and therefore we integrated many new features inside the terminal, so you can directly control everything through the PLC. But if your application, if you don't require these two channels in your application, but want to use the new features, you can use the EL51xx. Here you can directly connect one encoder with A, B, and C track, and it's really a compact replacement for the EL5101 because it's just a 12mm terminal. And the special thing on this terminal is that you also can use it as a two-channel solution. So you can also connect two encoders with A and B track. So if you don't need the C track of your terminal, of your encoder, you can use this terminal as a two-channel solution. At least you will save here 27% of space. If you have some applications with really, how to say, yes, with a more or less simple applications for counting, you can use the EL51xx. Here you have the chance to connect the single-ended TTL or open collector encoders directly to it, and therefore, sorry, yes, and it's really it's interesting from the cost side. Because Beckhoff is a technical leader and also want to stay it, technical products don't need to be missed. This is the EL5131 solution here. The main focus here is that you have additional two digital outputs included. These are push-pull outputs, so really fast outputs that can also be used as a tree state. The main focus was that you have here the possibility to set the threshold values defined on a special position, but also, for example, a special frequency or velocity. At least you will save here 2 PLC cycles because all the processes are internally already done in the terminal and you don't need to go through the PLC. So you will also save some CPU performance. Summary of the technical data is shown here. So all terminals have an encoder supply included. So it can be set between 5 and 24 volts. And the basic functions like save, set, lock, or reset the counter value is implemented. Main difference is that the variety of the functionality inside the terminal and how these functions or what are the special functions I will introduce you now with some applications. One of this is, for example, one of the new features is, for example, that we now have the possibility to set counter limits. So if you want to realize a modular access, you can set an upper and a lower limit, and then your counter value will really just counting between these two limits. Furthermore, you have also now the possibility to see the counter direction directly as a flag. Just compare the value before and after the PLC cycle and give it to you. So if the direction is positive, you will see a 0, and if it's a negative direction, you will see a 1, for example. But the terminal for sure also detecting inside all the signals, and therefore we can also detect a reversion direction detection inside the terminal, and this information can be used to detect a standstill. Furthermore, the micro increments that are probably already known from the EL5101 are also implemented here but we increased the functionality of the micro increments, and now also lower velocities are possible to detect and to work with the micro increments. The main focus of the micro increments is that if you have large shafts and working with standard encoders, you will have some steps in between. So really just steps between your increments, and with the micro increments, we are just implementing additional 8 bits to the counter value. We have also filter inside, and we have additional diagnostics included. The last 3 applications, like workpiece measurement, the continuous ledge, and the speed monitoring, I will explain in the next minutes based on some applications. The setup I used for these applications is just a servo motor of our AM8000 series with a multi-ton feedback. And on the other side, a standalone encoder with RS422 interface was connected with a 12-bit. The I/O setup is simple. It's an EtherCAT coupler with a servo terminal in the EL5102, and just used with 1 channel. Starting with the workpiece measurement. Workpiece measurement is based on saving the counter value, or so-called ledge. You have the possibility to save the counter value via the track C, or use the 2 digital inputs for it. You can also really adjust whether you want to ledge the value on a positive or negative edge, and the value is for sure saved inside the terminal and independent of the PLC cycle. If we check the application, for example, the part is going on and we're using a proximity switch, you will see a high edge or high signal on the digital 1, and then you can just enable this this flag, so enable ledge external positive edge, and if this high level is recognized, then the position value will be saved in a special register, and the valid flag will be set. After the part is running out, you will see a low level, for example, on your proximity switch, and here you have also the possibility just to enable and looking on the negative edge of the digital input, and after this is recognized, the value will be saved in additional ledge extent 2 process data, and also the valid will be set. The length calculation can be easily done in the PLC. For many applications, you will not only have the workpiece measurement, but you will also have further processing you need to do, and that's really the information that you need for synchronizing this different processes is mostly the time that you want to know when the process was started and when the process was, for example, this workpiece measurement was ended. And here we can use the distributed clocks functionality from the EtherCAT and working with the timestamps, because you have here the possibility for each ledge value to get a timestamp directly. Let's check it inside the how it looks like. We are starting the scope, and then you see that the counter value is just running up. You can enable the measurement and then just waiting for the first rising edge. The measurement is started, and with the falling edge, the measurement is ended, and the length is calculated. Then you can also start the next measurement. If you check the details, you see that you need to enable, first of all, both inputs, and then you will get the information about the ledged value. You will get the valid flag and also the time information via timestamp. One point that needs to be look on is that in this part you need to need an acknowledgement, because you don't want to overwrite your value inside the PLC. Therefore, you need to reset and then set it once more to start a new measurement. If you have a continuously or fast processes, you will need 2 additional PLC cycles to start a new measurement. And therefore, you introduced now also for fast and continuously processes the safe counter value as an enable continuous/extern data insights, so you can just activate them. Also shown here, just activate these and set them on true via the COE objects. Starting once more the axis. And starting the scope. The counter value is already started and counting up. You can enable the measurement and you see that all the data is continuously really saved, and the valid flag is coming up, and also time information is available here. You just need to enable now the process for one time, and then you will see for one PLC cycle the valid flag if the new value is available. Yes, it's not only the time information is interesting, but also, for example, the velocity is interesting in these processes, and this information you also can get out of the terminal. This information is mainly based on the internal frequency measurement, and you can define the frequency window inside this. We are counting all the periods and also the time. The main focus here is that the time measurement always starting with a rising edge, and we are really just measure the time for the total number of periods. Therefore, the accuracy is much higher here. The time measurement is done with a 10 nanoseconds resolution. It's 10 times better than the EL5101 does it. You don't need any distributed clocks, so if your EtherCAT master is not supporting distributed clocks, you still can use this feature. Furthermore, you have now also the possibility just to calculate inside the terminal the speed or RPM, but just parameterization of the numerator and denominator. Here, I want to show you how the frequency is looking like. So we are just checking the frequency value, and the reference axis is just the velocity that is calculating out of the motion control application. We are starting with some default parameters that are coming out of the terminal, and starting with some small velocities. And you see, after starting the scope, that both values, so the frequency value that is calculated inside the terminal and also the calculated velocity out of the motion control applications, are nearly the same. If we are increasing the velocity, you see that there's a difference, and this difference is just because of the different scaling. But both values are really running smooth next to each other. To see the difference, or to set it on the same level, to scale the values, you can use the time marker and check whether the marker window, the difference here, and then just calculate it and set our COE parameters in the right way. And the ratio of this here now, these two values is 1139. Just can tap it in and check once more how it now looks like. We are starting with the smaller frequencies. And see that now the values are scaled on the same level. And also if we are increasing the velocity, you see that it's really run smooth together. If we check some details, so just zoom in. Scaled once more. Yeah, need to zoom in a bit more to see some details. You see that the green one is the calculated value out of the motion control, and the blue one is the frequency, and you have some steps inside the frequency window, a frequency value. This is because we're using a frequency window inside, and this frequency window is doing averaging. And if you have some constant speed, you can use a large frequency window, because then you will have a better averaging or better filtering inside. If you have some dynamical applications, please use small frequency windows, because then you will also have a more dynamical value. How it looks like in the applications, if we are starting with a small window, here with a 100 microseconds. You see, just starting the scope, you see the value, and now we can step by step increase the window, going to 10 milliseconds. You see that the signal ratio get better. Now we can just increase it to 20 milliseconds. And it's always getting better and better, so the signal ratio and the signal level is more stable. See it in an overview. Here we have a really high signal noise ratio. And with a better or with a larger window, the signal ratio becomes better. If you check the details, you will see that here you have really dynamic values, so they're changing much more. And here you have some steps, because for the time window, as long as it is, you will have the same value. Yeah. So just a short summary of the applications. The workpiece measurement was shown, how it can be realized with just the 2 digital inputs that are already inside the terminal, and also the continuous counting without acknowledgement was shown, and the direct speed or RPM output via the parameterization averaging. Just want also to focus out the 4 bullet points of this new series, that we have really high density terminals here with a cost space saving of up to 75%. We have high cost savings inside, especially with the EL51xx solution. And we have also integrated more functions into this terminal. Please check the documentations. You will see that I was not able to show you all the functions that are available. We have also more performance integrated with counter frequencies up to 5 MHz for all RS422 interfaces, and we increases the resolution of the time measurement inside with 10 nanoseconds. Here, the overview, how the new terminals are now positioned in the product portfolio. Yes. Thank you for your attention. If you have some questions, feel free to ask me. Yes, this webinar can be also just listened later on our webpage. And if you have some suggestions for new topics, feel free to contact us. Any questions? You don't need to connect the C-Pulse. It's up to you. Or what was the question? If you will not connect the negative lines, you need to set the configuration to the TTL, because then it's a TTL encoder you used. You can connect both, but you need to configure the terminal the right way. If you have further questions, you just can also write us afterwards. Thank you.